Hello everyone. So we have got an interesting question here from the chapter of magnetic field. So let's go through the question once and understand what kind of values has been given and what quantities have been given. So first things first, we have got a ring, a uniform conducting ring, which has got a mass of pi kgs. All right, and its radius is 1 meters. Okay, and it has been exposed to a time varying magnetic field, the value of which has been given. Now, the first thing that should come to our mind when we think about time varying magnetic field is that an EMF is induced in that loop. Okay. Whenever we have got a time varying magnetic field and a loop has been exposed to it, an epsilon, which is basically EMF or potential difference, okay, has been generated across it. So, first things first, let's find out the value of that epsilon, that EMF. So, that epsilon goes by the value of minus a dB dt, right? The area is pi, and what's the dB dt? Any idea, guys? Yeah, I plus, it's basically d dt I cap plus t square j cap, I suppose. Yeah, t square j cap plus t square j cap. Now, upon differentiating it, this will basically be 0 I cap plus 2t j cap. And we have got a minus sign before it, so sorry. So this will basically be minus 2 pi t j cap. Alright, have I done a mistake anywhere? No, I've not. Very nice. So this is the first thing which we find out, the EMF which has been generated across that loop. Now, naturally, when we have got an EMF, a current will be flowing through it, right? Again, a time-dependent current will be flowing through it. Okay. So the value of current here will be very simple, epsilon by R, which is minus 2 pi t j cap by 2, which is minus pi t j cap. Right, this is the value of current which we have. So now the first question says time at which the ring starts toppling. The ring starts toppling. Now, whenever we have a word like toppling, we have to understand that it has got something related to torque. Okay. Now something related to torque. What can it be? Now, whenever we have got an external force whose torque balances out the torque of the gravity in the opposite direction, of course. Like for example, if you look at the torque of gravity as the direction of the torque of gravity, we see that this is mg, right? Suppose, let's say this is the point about which it's about to rotate. It is about to rotate. So the torque about this mg, and this is r, right? So the formula for torque, we know that it's r cross f, right? So if you look at it, it will basically be towards you. Okay, it will be something like this. The torque will be something like this. This will be the value, this will be the direction of torque for for gravity. Okay, so yeah, that won't be very relevant here. We will be trying to solve questions very quickly in our exam, right? But it's important to know the basics as well. So this will be the direction of torque for gravity. Now now we have got a magnetic field, right? Now we know that whenever we have got a magnetic field, we also have a torque that is associated with it, and it goes by the formula tau magnetic is equal to I A cross B, right? Where I is of course a scalar. Okay, pardon me. this will not have any scalar value. Okay, it should actually be something like this. Yeah, epsilon, this is Faraday's law, right? Yeah, this is the actual Faraday's law. Okay, this minus is only in terms of direction, which is also stated in Lenz's law anyways. So yeah, so its value is pi t. Okay, so yeah, let's put the value over here. It's equal to pi t. The value of area is pi. Area vector will be j cap into b will be I cap, whatever is given in the question. We'll just put that. Now we know the basics of cross product, right? Okay, let's bring this pi outside. This will basically be j cap into j cap cross I cap. Now j cap cross I cap, we know that j cap and I cap are perpendicular to each other, right? So it will be 1. And j cap and j cap, uh, there are 0 degrees. Now since the magnitude of cross product involves a sign value in it, where sign is the value of angle, will basically be the angle between the two vectors involved. It's 0, right? So sine 0 is 0. So yeah, the value of this will be basically pi square t. Now what will be the direction? Direction will be minus k cap, because you know j cap cross k I cap is minus k cap, right? So this will be minus k cap. Now let's have a look at the question here at the at the torque of the gravitational field. It's towards positive z. So the torque of the magnetic field is towards minus z, right? We have already shown that. They need to be equalized. So yeah, let's equalize them. Let's equalize the magnitudes. We will get the answer. This will be equal to mgr, right? Equal to mgr. Mass is pi, gravity is 10, radius is 1. This is pi square t. Cancelling pi. So time is 10 by pi seconds. And we have our first answer, 10 by pi seconds. Yeah, option A is the correct answer. Okay, let's have a look at the second question. Heat generated through the ring till the instant when the ring starts toppling. Now we know that the value of heat generated is basically this, right? This should be a very familiar formula to you. Now we'll just simply put the values over here, right? We'll simply put the values here. I'm sorry. T square dt. Therefore, t cube by 3, right? Now I should have put the values of the limits there, but it would get clumsy, so I did not do it. So till the instant, the time will be till 0, till the instant when it starts toppling. It starts toppling at 10 by pi seconds, right? Let's put 10 by pi here. Yeah. So this will be 1000 by pi cube. This is divided by 3. So yeah, this is in joules, right? Let's divide this by 100. I'm sorry, by 1000. So this 1000 will be cancelled, right? So there we have the answer. 2. Okay, let's cancel the pi's here as well. I'm sorry, did I go somewhere wrong here? Okay, okay, there will be pi square over here, right? Because we have got two pi's here, they will multiply to give me pi square. Yeah. So yeah. So yeah, the answer will be 2 by 3 pi. 3 pi kilojoule. There you have it. You've got our answer. And yeah, if you like this video, do consider sharing it with your friends. Okay, because that will really help me a lot in publishing free content. Thank you.